Alright. Class is beginning now. 15. I'll give them a moment. Alright, let's begin. Alright, good morning.
Hello.
Alright, we have Annalise. Everybody really we have.
Hi, sir.
Good morning.
Good morning, sir.
Hey, Feng, it's been a while. How are you been?
Sir, I'm tired.
It's
No. Sir, I want extra. Sir, can I have extra sleep, please?
It's soon be the end of the week. One more day, Feng. One more day. Good morning.
No, sir.
Good morning.
No, sir. I want it now.
You soon get it. But good morning, everybody. How's everyone doing? Alright.
Sir, I don't have a good day.
Don't worry.
Worst day.
I'll make your day better. So look at this for me now. Yesterday we had some internet issues, so we're gonna now go through very closely what we wanted to do yesterday and today. Alright? So I have the PDF files. So I'm gonna screen share for you. Let me know. Can you see these
Sir,
diagrams?
your mic is really loud. Like really loud.
I think I'm just shouting. My bad. Once again. Is that better now?
Yes, sir.
Alright, yeah, I was shouting that, my bad. Alright, so let me just do on screen. Can you repeat that for me? One second, I'm gonna put you guys over here. Alright, can everybody see this PDF over here?
Yes, sir, with the triangle with 8 equals half the...
Yes, this is the kite. Alright, so this is what we've been talking about. Now we have a perfect diagram to explain how a kite looks. Alright, so we call this distance across B, as you can see. The height is called capital D, and also it's called common D across as well. Alright, and I told you the formula for the orange area was a half small d times big D over here. Alright, so you could say half small d, or you could say a half L times B. Would not be the same thing? Wouldn't small d right here be the same thing as small b?
Yes, sir.
Right, so you have two ways to write this formula. Either you say half LB or half small d times big D. This PDF will be on the portal, so if you want to take the notes, you can definitely check it after. But you should have these now for the homework. So here's the first question we're going to do together. It's brief revision. Let me just check who's that. Alright, good morning, Aliana. Good morning. So we have this kite, and the question would typically say, find the area of the kite shown. Right? What do we know? This distance is called small d. Alright? And can we find big D, which is the distance from the top going straight down? How can we find that?
Sir, find the area of the kite here. So you will need to go half capital D.
Yes.
Capital D times
Big D. Yeah, a common D, right. So look at this for me now. Remember, this distance from here to here, we're going to add them together. So what is 4 plus 4? 8. Right. So put that for me. D centimeters, which is the distance from here to here, is going to be 4 plus 4, which is 8 centimeters. Alright? And now the distance from the top to the bottom, which is big D, is going to be equal to 3 plus the 12. Alright? And that gives us 15 centimeters. Does everybody understand how we got those? Everybody clear? Alright, that sounds like it's clear. We're going to use the formula now. So it was a half D times D. Right? Small d was 8, so we put in 8 for a small d. 15 was big D, so put the 15 there. Then now we say a half times 8, which is just 8 divided by 2. It's going to be 4. And then now we find 4 times 15. 4 times 15 gives us 60. But are we finished? Let me ask Aliana, are we finished with the question? What are we forgetting? The question says find the area of the height in what?
Centimeter square.
So you must put, hence the area of the height is 60 centimeters squared. I'm going to give you 1 minute to finish writing off this for me. Let me just zoom out for you. There you go. Alright, that's how a typical question of finding the area would have been. Let me just check the comments section. 1 second.
Yes, sir. I was asking when are we going to go through our homework?
Right, the homework from yesterday, correct?
Yes, sir.
Yeah, we're gonna go through after we finish going through what we were to do yesterday. So we're gonna go through the homework in a few minutes.
That homework is pretty manageable.
Thank you. I'm glad that it was manageable. Good morning, Corey.
Good morning, sir.
Right. So yesterday we were to have we were to move on from another topic, but because of the internet issues now, we're just making sure you understand how to calculate area. So we have this lovely little kite here, and we were given the distance of 4 centimeters plus 4 centimeters. That would have given us the distance D, and we're given 3 centimeters plus 12. That would have given us the big distance of 15 for a capital D. Then now we use the formula of a half D times D, which is going to be a half 8 times 15, which gives us 60 centimeters squared for the area. Clear, Corey?
Yes, sir.
Alright, good. Now, I'm going to give you one question to write down to do as classwork. Here you go. So, what if the kite was turned on its side? How would you attempt this question? So, quickly.
So the same way, right?
Yes.
It's just sideways.
Yes. So, it's the same way, but sometimes it's hard for you to find the values. So, where would be common D?
So common D will be where 2 is.
Right. Yes. This would be common D, and capital D would be where from 5 goes straight up. So you're gonna add those together and tell me what your answer would be. 1 minute. So draw the kite and then answer this question.
Sir, I didn't get to write off with the thing which you are showing at the top.
Here we go. Here we go. Here we go. Check the comment section. Yes, I'm recording. Don't worry. I'm recording right here. Lovely red button. So as I said, you guys might think I'm not recording classes because you don't see a red button, right? But it is always red right here. Okay? So I'm always recording. Alright, 1 more minute. So, this diagram now it's on its side. So you can take a picture of the kite if you didn't get a draw it off. This diagram is on its side, right? So you're gonna now find the area of this kite that's on its side now. You have 2 plus 2, which will give you 4 meters, correct? And then you have 5 plus 2, which will give you 8 meters. So therefore, big D is equal to 8 meters, and common letter D is going to be equal to 4. So you're going to put now 4 times 8 times 1 divided by 2. And the first person...
Saying it, sir. You're saying it.
Oh, sorry. I thought it was finished. First person to get it correct or first person to tell me their answer wins a prize.
Sir, do we have to draw the kite, sir? Because it's pretty difficult to draw it on the side.
So, alright, how far are you? So you finished drawing the kite yet?
No, sir. I just finished.
Just answer the question. Yeah, you don't have to draw the kite yet. Then just answer the question quickly. So put the formula and then pick out your measurements for the formula. Because today we're gonna learn trapezium, but just before I go to the trapezium, I'm just gonna briefly go back to the homework. Anybody
So
finish?
when we gonna do rhombus or rhombus? or are they the same thing?
Rhombus. Yes, that is on our agenda. So the next thing we're gonna look at is a trapezium, right? But rhombus is definitely coming into a close second. So don't worry, we're almost there. Alright, anybody have the answer yet?
So I forgot to say the yes.
Alright, so let me hear firstly from Naima. What's your answer, Naima? Camera on for me, Yifeng. Can you repeat that for me?
16 meters square.
16 meters squared?
Yes, sir.
Alright, anybody else can confirm? Because I'm gonna now check it.
Wait, so what did she say?
She said 60 meters squared.
So I'm calculating it now.
Alright. Morning, Caleb. So, let me tell you the answer now, quickly, because we have to move on. It's gonna be 5 plus 3. Right, that's gonna be 8 meters.
I think I got it, sir.
Alright, what's your answer?
Sir, when I calculated it, sir, I got 16 meters square, but it's probably wrong.
Oh, Naima, you said 16. Oh, my bad. So yes, you're correct then. Because if
16.
yes, 16. So both of you guys are correct. Clap yourselves. Because if we have 8 meters multiplied by 4, that's 32. And half of 32 is 16 meters. So the answer is 16 meters squared. You have 2 other to practice. I'm going to put them on the portal. Alright? But now we're going to look at trapezium. Alright? So look at this one now. A trapezium, as seen below, the 2 trapezium below, right, has 4 sides. K, L, M, N, or in this case P, Q, R, S. Right? And it is a
In my case, sir, when I was learning how to do trapeziums, those are the hardest ones to do, sir.
Yes, I know. So that's why I'm gonna go through how you're gonna count the squares. So don't worry. So look at this one now. Follow with me. It's a closed figure, right? And it is bounded by some lines that don't intersect, right? So it is a quadrilateral, right? So a trapezium is a quadrilateral, which we know is having 4 sides, or which we know has 4 sides. A trapezium is a quadrilateral, which means it has 4 sides. Alright? But also, in this case, how many arrows do you see? Remember I told you that arrows mean what?
That the both sides are equal, sir.
Right. So look at this one now. How many groups of arrows do you see?
Sir, some would have 2 and sometimes some would have 4.
Right, but in this case we only have 1 above and 1 below. So I'm gonna ask now. Let's see who can recall. Annalise, what do you think these 2 arrows mean again? We have the line SR having an arrow and the line PQ. Alright, so if Annalise doesn't get it,
to each other.
yes, Benjamin, good job. I want to hear from Annalise though. Annalise, you got saved by the Ben.
Yes.
Saved by the Ben.
Oh, you said Annalise. I never heard that.
Yeah.
His nickname is Benjamin.
But yes, so look at this one now, guys. Pay attention. SR and PQ are parallel. So therefore, the rule is a trapezium must have 1 pair of parallel lines. It's a quadrilateral, yes, but it must have 1 pair of parallel lines.
Sir, but what if it doesn't have parallel lines? That means that it's not a trapezium then.
Yes, right. It's another quadrilateral, which we'll get into, like rhombus, etc. Alright? So look at this now. Do you realize how we called this parallelogram? We called it trapezium. Sorry, this trapezium we call it trapezium KLMN. That's how we identify a trapezium, by calling it on its 4 sides. Alright?
Sir, but any letter can go at the beginning, right?
Yeah.
It has to be.
As long as you start from 1 letter and you go around. So you could have said NMLK and that would be fine. Alright? So whenever you're identifying a shape, you must call the letters now to identify that shape. Okay? So the next type of trapezium we're looking on is something called the Isosceles Trapezium. Alright? Look at this trapezium. Tell me what's different compared to this one right here.
Sure, that one has 2 parallel lines and one has 4 parallel lines.
Yes. Why? Look at this one now. This has a line throughout on both sides.
Yes, they're equal angles.
Yes, equal angles. Because if you can recall, what does an isosceles triangle mean?
It means it has all even sides. Right?
Sure.
Like two or more even sides. 2 or more.
Let's go back to the textbook. Go to page for me. Wait, Benjamin. Listen to your group, classmate. Alina, repeat that for me.
Sir, where only 2 sides are equal.
Wait, I said that.
You said all sides are equal.
No, and then I corrected myself. 2 sides or more.
Oh, sir.
That was not right.
So when are we gonna use book 2, sir? Because I don't have book 1, sir.
This is book 2. This is book 2 you have? Or you have the other version?
So one is the same for the kids in art school.
Okay, I use that book as well. So sometimes you see me using PDFs. Those are coming from the book 2 as well, which is the volume 2. But in this case now, I just want to go back over the types of triangles. So go to page 310 for me. Right, we have scalene, isosceles, and equilateral triangles. So let's quickly go over those types for me, because I realize some of you guys might not know exactly what that means. So scalene, yeah, so we're gonna go through them. I'm gonna take a picture, you're gonna check the group for me, and we're gonna discuss it quickly. Scalene triangles means it has no equal sides in length and no equal angles in measurement. Alright, let me take a picture. Check the group for me now. 1 second. So scalene has no sides, no angles equal. Isosceles, as Aliana said, has 2 sides and 2 angles that are equal. There we go. Alright, can everybody see the picture? It should be in the group now. Page 310. There we go. Good. And finally, equilateral, as the name suggests, equi means that everything is equal. The 3 sides and the 3 angles are equal. Alright? So that's why we have an isosceles trapezium now. So let me ask Isabel. Now knowing what isosceles triangle mean, put a definition to isosceles trapezium.
Isosceles trapezium has 2 parallel lines and
look at the sides and angles. If isosceles triangle had 2 sides and 2 angles equal, what does an isosceles trapezium have? Isn't it going to be the same length right here, over here, and also the same angle between here and here?
oh, I was looking at SRPQ.
Oh no. So this is the isosceles. Why? Because it has these lines running through. Okay? So
Sorry.
right. So make a distinction for me. Put this as an isosceles trapezium because it has 2 sides that have the same length, NK and ML, but also the same angle between them both. Alright, good. Now the next thing we're going to learn is how to find the area of a trapezium by the easiest method we learned, which is the counting square method. We did that for the parallelogram, we did that for the kite, and then we're doing that for the trapezium. Now for the trapezium, let's say we're given this diagram. Alright, how many sides does it have again? How many sides does a trapezium have?
Oh, it's a quadrilateral.
4. Good. You have the line AB, line BC, line CD, and line DA all enclosed. Alright? And for you to find the area, we said that you can count the squares inside of this region. Alright? So here we go. Let's quickly use a method to count the squares. Firstly, you must count how many full squares do you have. Clear? So if you're given this trapezium to find the area, you're going to count the full squares. So how many full squares do you see here? 1, 2, 3. Let me draw on the diagram quickly. 1 second, let me just draw on the diagram.
Wait, is there a difference between a trapezium and a trapezoid?
Yes.
Or is trapezium the plural of trapezoid?
No. Both of them still are one shape. There is a difference in terms of its construction, and I'll go through it when we reach that stage. Alright? But trapezium, right, they must have 2 parallel lines. So let's count the full squares. Let's count the full squares. Let me identify it with this marker. So this is the first one. No, let me use another color. Alright, here we go. We use yellow. This is the first square.
About like
This is the second square. This is the third square.
7, about 6 or 7. I don't know if I'm correct though.
Let's check it. 4, 5, 6,
8. It's actually 8. It's actually 8.
7. It's 8, right? It's 8 full squares. But what did we say we do for the parts that are halved? Let's ask. Wait. Let's ask, because I want everybody to participate. Let's ask Jude. What should we do for these half squares? Jude, are you there? Alright, I'm going to put it in a waiting room.
Yes, sir.
Okay, good, you're there. What should we do for these half parts of the squares, Jude? If we have 8 full squares, how can we find the area of these half squares?
You just count the squares in them, sir.
Right, so if you have one half here and you have another half over here, can't we add them to make one full square?
Yes, sir.
So I'm going to say this half plus this half gives me 1. So I'm going to say I have 9 so far. Let's try another one. How about this part right here?
It doesn't give you 1.
Can you repeat that for me?
It doesn't give you 1.
Why does it give me 1?
It's the one near to the C angle. It's more than a half. Like it's a more than half.
Oh, okay. So you're saying, therefore, that they're not identical. So, which would be a better part for me to call it 1? I could say that this and this part, right? Wouldn't these two be identical? Right, so that's going to be 1.
Sir, I see one. Sir,
Yes?
I see one.
Where do you see 1?
So you see, like,
So when you take the half and calculate the equal to 1.
oh, wait, sir, look.
Yes?
See the one that's side of 8?
Yes?
One
That's it?
that's side of 8, right here, yes. And then, a little bit above right there, it makes one whole.
There you go.
Yes.
Everybody give him a round of applause for me.
Clap. Go Ethan.
Let me check if everybody sees it. Let me identify it. So Yifeng,
I see it, sir. I see it.
good. Because look at it for me now. This is 1. This is less than 1 rather, right? So how do we...
that you could do?
So look at it.
Actually, never mind.
Yeah, so look here, Benjamin. Doesn't this section go into another square? Right here. So what?
Yes, sir.
So what Yifeng says, and he's right, is that we can say this section...
I see it now, sir. They equal to the same thing, sir.
Excellent. So that's another one. Good job, Yifeng. So far we found 2 squares. Do we have any other left?
Realize that.
Yes, that was a good spot by Yifeng.
And the one beside the 3 and the one beside the box which you just highlighted.
Excellent. So therefore, that's another one. And this is the final one. How many squares do we have in total, therefore? Let's add them. 1, 2, 3, 4, 8. This is 9. This is 10 that Yifeng
That's
found.
11, I'm guessing.
And it's 11. So you would put your answer as 11 centimeters squared. Got it, everybody?
That's an easy way to do it.
Yeah, it's very easy. But what if you missed this? Like how Yifeng found it, some persons would have missed it.
Realize it,
Yes,
sir.
I didn't even notice it.
Yeah, so that's what I'm saying. Good job, Yifeng. Alright? So let's do another question now. Okay.
Sir, this diagram didn't even notice it either. And there's one there.
It's look, yes, right, but they still got the 11 centimeters though. So our answer is correct, but how did they get 11 if they didn't spot it? Let's look at it. We know that they're gonna get 1, 2, 3, 4, 5, 6, right? So they divide it into 3 parts. Okay?
Oh, sir, now I get it.
Alright, so look at it from now. They divide this trapezium into 3 parts. Put that down for me. So we can assume this trapezium, A to B to C to D, is divided into 3 parts. So this is the one I want you to draw now. Because this was just to help you understand from Kite how you can break apart it. But now we're going to look at the counting method for trapeziums, which is where you divide it into 3 parts firstly. So you're going to have basically 2 triangles and a rectangle. Does everyone see that?
2 triangles.
Yes.
So I'm drawing the trapezium.
Alright, sure.
Yeah, mine is probably a bit bigger than the one which is showing the diagram, so yeah.
Oh, okay. Alright, so once you divide it into 3 sections, you're going to have a triangle AWD, a rectangle CDWX, and another triangle BXC. Am I going too fast, or is everybody with me?
I have to redraw mine.
Alright. What did you say, Isabella?
I'm not done drawing.
Okay, let me give you a moment because I don't want to go too fast. So just divide now your trapezium into 2 triangles and a rectangle for me. Alright. Once you've done that now, we're going to do some calculation. So this method that we did was very fun, right? But it does take some very precise observation. What if you forgot that there was a little section there? What would you do? Right? This takes rid of that. So it says now, once you're finished, you're gonna now take this down for me. The area of the trapezium A, B, C, D is equal to 1/2 of the square, right, plus the area of the rectangle plus 1/2 of the rectangle BXCY. I'm going to explain that. Alright. Is everybody finished drawing?
Not yet, sir.
Alright. I'll give you one more moment. So 2 things we have to complete today. We have to learn how to count the squares in a trapezium, and then finally we're going to learn the formula to calculate area in a trapezium. So quickly, let's get started. So if you're not finished, just take a photo and then complete it after. So here's the first thing we're going to do now. What would be 1/2 of the square AWDZ? Look at it closely. We have 4 squares, right? 1, 2, 3, 4. Wouldn't half of those squares be exactly 2? Does everybody see that? AWDZ is 4 squares. 1, 2, 3, 4. So what would be 1/2 of 4?
2.
2. So let me show you where those 2 came from. Let me show you. This would have been the first square. Wait, let me use a brighter color. This would have been the first square. But then now the second square comes from this section plus this section. Does everybody see that? So that gives you 2. Good. Alright? So that's where we get the 2 from. Good. Now let's look at the next section. It says the area of the rectangle CDWX. What do we say the area of a rectangle is again? Just counting the number of squares. Right? So we're going to say 1, 2, 3, 4, 5, 6. So we're going to put 6 down for that area. Clear, everybody? And then the final square we have over here, or the rectangle, we have CYBX, and we're going to find 1/2 of it since we only want this line. So what is a half of 6?
3.
3. That's why we get the 3 right here. Okay? So this is a little bit more nuanced, which means basically you have a little bit more calculation with it, because you have to find a half of each. Alright? So just to repeat, in this trapezium, we turn it into a very large rectangle. Right? The very large rectangle I'm referring to is A to Z, Z to Y, and Y to B, and then back B to A. That's the very large rectangle I'm referring to. And once we've done that, the next thing to do is to break it apart into a triangle on the right or on the left for you, another triangle, and in the middle section you turn into a rectangle. Okay, good. Alright, and now once you've done that, we're gonna just add them together. That's why you see plus plus. So what is 2 plus 6 plus 3? The original answer we got when we added the individual squares, which was 11. So this is the official method on how to add the trapezium together. You can do this method, but just make sure you don't make any errors. Clear?
Yes, sir.
This method would ensure that you don't make any errors, because what you're going to do, you're going to actually calculate instead of just trying to pick apart where that little section is, because I would have missed it sometimes. I'm human, so I would miss that there's a little section there, and then we would wonder, how did my answer become 10.5 when it should be 11? Because you missed out a little tiny portion there. Okay, good. So another way of looking at it though is this method where you can create another trapezium. So let me highlight where our trapezium was. We said our trapezium was A to B, B to C, C to D, and D to A. Right? What we did therefore was to kind of flip. Let me use another color. We flipped this trapezium on its back and created another one that went from B to A.
So that means you'd have to minus.
Yes.
Minus half of it. So divided by 2.
Yes, basically. We're gonna know half.
So basically
22.
what we're doing right now is we're finding the area of a parallelogram.
Well, not really a parallelogram, because it's still a four-sided figure, but what we're doing really is just to form it into a parallelogram and then half it.
Yeah, that's what I'm saying. We're at this point in the stage.
Yeah, okay, I got you now. Because let's read it. Another way of looking at the problem is to place 2 trapezium, right, and then form a very long parallelogram. So let me highlight it for those who don't see it. Let me use red. Red is the best color to highlight something. So here's the parallelogram. There we go. All the way over here, and there we go. And then we just half it. So we're gonna count the number of squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then all on the lowercase you'd see 11 as well, right? And then what you're gonna do now to find this section that you originally wanted, you're going to just what? Half it. Clear, everybody? So there is a total of 3 different methods to count the number of squares. It's either you're gonna count it like the method you learned in Kite, or you're going to count it using the trapezium rectangle method, or you're going to count it using the parallelogram method. These PDFs are on the portal, so I want you to practice it now on these 2 questions. You can use any method you'd like, right? But you can't use the same method twice. That rhymed. That means it's right. There you go. Alright? So for 1A, you must use either the Kite method, rectangle method, or the parallelogram method. If you selected one of those, you only have 2 other choices to use for the second one. Is that clear, everybody? Clear?
Yes, sir.
I think you guys are really enjoying this class. I don't know why.
Hey, so if you have what is the other rhombus called? The trapezoid called the one number 1.
Number 1 here.
Number 1A.
Mm-hmm.
You could just cut cut off one side and put it to the other and turn it into a rectangle.
Yeah, right. Or you could just extend here into a full.
That's what I mean.
Okay,
Right,
gotcha.
oh wait, no, that's not what I mean.
Right,
But,
and then now you just say you have two triangles. So I'm helping you
You
guys.
have to find the area of the triangle. So that's too
No.
complex for my mind.
No, you don't have to find the area of the triangle, but rather, doesn't the
You have to
triangle?
find one.
Listen now.
You have
Isn't
to find one.
you don't have to find the area of the triangle? Isn't a triangle half of a square?
Oh yeah. Wait, so
So-
you have to find the area of a square and then just divide it by 2?
What is the area of a square by counting the number of squares in here? Isn't it 4? 1, 2, 3, 4.
Oh yeah, it'd be 2.5. Yeah, wait no.
It'd be 2.
It'd be just 2.
It'll be just 2, right?
What? Oh, okay. So
I see you're getting it. You're pulling on it, and you're very
so
close.
much easier.
Yeah, so this is way easier. So you can try that method, and then for the last one now, I want you to practice turning this into a parallelogram. So you're gonna flip it on its side, right, and then have 2 of it turning into a very large parallelogram, extending all the way out there, coming back down, right, and then making your parallelogram just the same. Okay? I think you guys like this topic. Was it that hard? Alright, I'm hearing a lot of no says. That's good. Alright, so I just want to introduce to you how to get the formula now. Alright, we're gonna learn introduction to the formula of trapeziums. We're not gonna learn the formulas today because we only have roughly 9 minutes. So in those 9 minutes, let's break apart on how you would find the formula for a trapezium. Alright, let's look at a parallelogram for a second. Let's look at this lovely parallelogram. Okay? Who left? Alright, someone left. Alright, here we go. Let's say this distance that goes across is A plus B. Why is it A plus B? Let me show you. A part of this distance was B in the highlighted region, and then a part of it was also A. So if I want to know the total distance, wouldn't that be A plus B? Is that clear, everybody?
Yes, sir.
Right. So what I'm saying, therefore, a trapezium, or a parallelogram rather, is made of 2 trapeziums. Here's the first one. This is the first trapezium, and then now the next trapezium is over here. So to find the formula, we're gonna now picture that there is actually 2 trapezium in a parallelogram, and then you're gonna say the first section, that's gonna be the B, which is the base, and the next section is gonna be the A, which is the height of the parallelogram. Because when you flip it, it's gonna put the height down here. We're gonna say that's equal to A plus B. Alright? The next thing now, we're gonna say then therefore the area in a parallelogram, the area in a trapezium is found by a height, a given height. Okay? So it's like a triangle, for example. A half base times height, for example. But do you see another value in this bracket? Isn't it a A? Does everybody see that?
Yes, sir.
Let me put the triangle, for example. What if we only had this? Look at this one, everybody. Stop writing. This would be a triangle, right? And the formula would have been a half base times height. Clear?
Yep.
But because we have a new distance up here, look at this one now. We included an A up here. The distance is now increased. So therefore we have to say not a half base times height, but rather a half A plus B times height. Does that make sense? Let me go again. Let me go one more time. Here we go.
Yes, sir. Go one more time.
This is a triangle. Is there any distance above here in this triangle? No. Correct?
No.
So the only thing we have in this triangle is a B for the base and a height for the H. Clear? So if I wanted to find the area in this triangle now, I would just say a half b times h. Everybody remember that, correct? Now look on this trapezium. Let me draw the trapezium now. Here we go. Here we go. Would I go back to this point or would I extend it to this point, and why? Where would I draw my trapezium point? Here? Or am I going to draw it like a triangle? Oops, the time ended. I was so close to getting them to see it. I was so close to getting them to see it. Let's try again. Alright. You guys are so close to seeing what I'm trying to show you. So let's just quickly go back. Alright. We were on this diagram. Right? And I was telling you, because we have a trapezium, the trapezium has a distance that goes across. Isn't that correct? It's called A. Everybody see this A, correct? Right here. Does everybody see it? Hello?
Oh, sorry, I didn't realize.
Okay. So you do see it. So because we have a distance that goes across, we must add this in the formula. That's why we have a plus b. Alright? So it's basically the same formula as a triangle, but because we have a distance that goes across, we add that to the base. And then we multiply that by the height. Alright? Good. So that would be the formula for a trapezium, based on the simple fact that we have a new distance that goes across. We must include that into the formula. So that's why we have a half a plus b times the height. Does everybody understand how we got the formula? Hello?
Sorry, I thought of it in a different way.
Okay, how did you think of it? I like to hear input. What did you think of it like?
So, two trapezium equal one parallelogram, and then a parallelogram, the formula for it, it's base times height. And then you put half there because it's two of the same. So if you times it by half, you'll together divide it. And then,
I see that. I see it. But what about the A though? So we know that the formula for a parallelogram is a half, right? Just like you said. Sorry, base times height. But what about the A? Right? You have to realize that since there's two trapeziums, the distance across will be broken apart in two. You see that? Which is A and B. Clear?
Sir, so half A and B times the H.
Yes, a half A plus B times the H. That's the formula for a trapezium. Alright? So write this for me now. This is the final part. The area of one trapezium is equal to 1/2 of the area of a parallelogram. So as Isabella said, which is a really great way of looking at it, you just put the half of the formula for a parallelogram. Good? And that's it for today, guys. So just to repeat, your homework is going to be now using your... Wait, that's not the homework. Hold on, let me go back up. Here we go.
You wanted to give us two already.
Yeah. No, remember that we're not going to have class tomorrow, and I won't see you guys until Monday. So you're going to have these two to do for trapezium, but then now to practice the formula, I want you to do one question under calculating it. So here we go. Let me quickly give you that question. Let's say you have this trapezium. Alright, take a picture of it or quickly draw it in your book. Practice it for me. You have 5, 13, and 4.5. Find the area of this trapezium. So you have 3 questions to do for homework until Monday. Sounds good? Everybody clear as mud? Clear as mud, everybody?
Sir, I don't understand this.
Yes, sir.
Alright, 1 second. What would be the base, Michael?
5.
No, the base, remember, look on the diagram again. The base of a trapezium is always going to be the distance that goes at the bottom. Isn't that correct? So look at this. Yeah, so look at this. What's the base here?
13.
13. So you do understand. So it's 13. So put that from the B is equal to 13. Before you go, B is equal to 13. B is equal to 13. What would be the A, Michael? Remember, look back on the diagram. A is equal to the distance at the top. So what's A?
5.
5. There you go. A is equal to 5. You do understand. And then now, the height is going to be the distance that goes from the bottom going up. So what's the distance from the bottom going up?
4.5.
4.5. Good. So height is equal to 4.5. Good. And then now, using all of those information that you just told me, I didn't tell you, right? You're going to use this formula now, Michael. A half A plus B times a H. So put in each of those values, work it out, and that would be the area for your trapezium. Understand?
Sir.
Good. You're welcome. No problem. Alright? And if you have any more questions, feel free. I'm going to press the stop on the recording now.